the quadratic formula. So we've looked at a couple of different ways to solve quadratic equations. We've solved them by graphing, we've solved them by factoring, and today we want to take a look at using the quadratic formula to solve a quadratic equation. And generally you use it when a quadratic equation cannot be factored. So we have the quadratic formula here, and this is how we'll solve quadratic equations with this formula. So we'll try an example here. We'll take a look at the one in part A. So we have 2x squared minus x equals 4. So before we could use the formula, we want to make sure that our equation is in standard form. So standard form again is ax squared plus bx plus c. So you notice that all that should be equal to 0, and you notice that we have a 4 that's got to be moved over. So if we subtract the 4 to the other side, we'll have our quadratic equation in standard form because we'll have 2x squared minus x minus 4 equals 0. So now we have something that looks like the format above. Once that we have the equation in standard form, we want to identify a, b, and c in the equation. So in this particular one, a is 2. We have a -1 here for b, and c is -4. So we'll write that down. A is equal to 2, b is -1, and c is -4. Once we've identified a, b, and c, the next thing is to write down the formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now we're ready to take a, b, and c and substitute into the formula. So x equals negative, so b is -1, plus or minus the square root of, so -1 squared minus 4 times a is 2, and c is -4. That's all over 2a, or 2 in this case, 2 times 2. All right, so we've successfully substituted everything into the formula. Next thing we want to do is to start to calculate. So x equals -1 times -1 is +1, plus or minus square root of, so -1 squared is 1. Now what you want to do when you're calculating this, always treat this as a -4 and multiply it to the two other numbers, to a and c. So -4 times 2 is -8, and -8 times -4 is +32. And that's all over 4. Last thing is to calculate what's inside the radical. So 1 plus or minus the square root of 33 over 4. Now, when you're doing these, they may ask you to leave the answer in simplest radical form. They may ask you to leave it to a number of decimal places. So let's say for simplest form, what you want to do is take a look at this 33 under the radical. The only way we'd be able to simplify the radical is if there are any factors of 33 that are a perfect square. Since there aren't, here we're in simplest radical form. So we could say that this is already in simplest radical form. Okay, since the 33 can't be factored out into anything that's a perfect square. Let's say they wanted it to the nearest hundredth or 2 decimal places. Then what we'd have to do is actually break up into two equations. So we could say that x equals 1 plus the square root of 33 over 4, and x equals 1 minus the square root of 33 over 4. And then we could just use the calculator to come up with the solutions. So we'll go to the calculator, get a calculator page. So it was 1 plus the square root of 33 divided by 4. Okay, so 1 plus this, interesting. Okay, let's try it again. 1 plus square root of 33 divided by 4. Okay, so to the nearest hundredth, or to two decimal places, 1.69. Then we want to do 1 minus the square root of 33. So I'm just going to copy and paste that and change the plus sign to a minus sign. And negative 1.19 is the other solution. So we'll go back here. So the first one was 1.69, and the second one was negative 1.19. So these are our solutions to two decimal places. So depending on how they ask for the answer, these are the two possible ways that we would answer this question. All right, taking a look at part B here, we want to do the same thing. The equation is already in standard form. There's nothing that we need to do to change it around. So we want to next identify A, B, and C. So A is 1, B is 4, and C is negative 3. Once we identify A, B, and C, we'll write down the formula. And then we'll insert A, B, and C into the formula. So we have negative 4 plus or minus. So 4 squared minus 4 times A is 1 and C is negative 3 over 2 times 1. All right, so now that we have that filled in, we can start to calculate. So negative 4 plus or minus. So again, 4 squared is 16. Negative 4 times 1 is negative 4. Negative 4 times negative 3 is positive 12. Okay, next step is to add what's in the radical. Okay, so again, if we want simplest radical form, we have to take a look at the radical. So square root of 28, and determine if we have factors of 28, one of which is a perfect square. So we do. We can say that the square root of 4 times the square root of 7 are your factors of the square root of 28. Square root of 4 is 2. So we have 2 square root of 7 would be the square root of 28 simplified. So the next step would be to write that in. So negative 4 plus or minus 2 square root of 7 over 2. We see that we can divide what we have here. So it would be the same as doing this, negative 4 over 2 plus or minus 2 square root of 7 over 2. So negative 4 over 2 would give us negative 2. And 2 squared root of 7 divided by 2 would give us the square root of 7. So here's our answer in simplest radical form. To get it to two decimal places, again, we could break this up. And then we could use the calculator to see what the answer is. So we go back here. So we have -2 plus the square root of 7 and -2 minus the square root of 7. So our solutions are 0.65 and -4.65. Okay, so our solutions here, 2 decimal places. All right, so we have 2 ways to answer it, again, depending on how they ask us to present the answer. So we have simplest radical form, and then we have to the nearest hundredth or 2 decimal places. All right, the next thing we want to take a look at is something called the discriminant. Now, the discriminant is only that expression underneath the radical. So the radical has nothing to do with this. In other words, b squared minus 4ac is the discriminant. So this calculation would help us determine how many real solutions we have in the equation. So for example, if what we have calculated in that expression is positive, we know we would have 2 real solutions. If what we calculate in the expression is equal to 0, we would have only 1 real solution. And if what we calculate in the discriminant is negative, less than 0, there are no real solutions. So let's take a look at how that works. So here they give us a quadratic equation, -2x squared minus 3x plus 5 equals 0. And they want to know how many real solutions are there. So again, the first thing we want to do is identify A, B, and C. So in this case, A is -2, B is -3, and C is 5. We'll write down the expression for the discriminant. And now we'll substitute A, B, and C into the expression. So we'll have -3 squared minus 4 times A is -2, C is 5. So let's see what we have. -3 squared gives us 9. -4 times -2 gives us +8. 8 times 5, 40. So our discriminant is 49. Since our discriminant is positive, we have 2 real solutions. Okay, so they were asking for the number of real solutions by calculating the discriminant and finding that it's equal to 49. We know that this quadratic equation will have 2 real solutions. Okay, in part A here, they want the number of real solutions. So again, identify A, B, and C. So here A is 2, B is -3, C is 7. So we start with B squared minus 4AC. So that's going to be negative 3 squared minus 4 times a is 2 and c is 7. So negative 3 squared will give us 9. Negative 4 times 2, negative 8. Negative 8 times 7, negative 56. So we have negative 47 as the discriminant. We go back to our chart and notice that the discriminant is negative here, so there are no real solutions. So no real solutions in this case. If we take a look at part B, again, A is, well, before we do anything, we have to get this into standard form. So we'd have to subtract the 6x, subtract the 5. So that'll give us x squared minus 6x minus 5 equals 0. Now we can identify A, B, and C. So A is 1, B is negative 6, and C is negative 5. So now we write down the discriminant, b squared minus 4ac. Plug in A, B, and C. So B is negative 6. Square it, minus 4 times A is 1, C negative 5. Okay, so negative 6 squared gives us 36. Negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20. So that gives us 56 as our discriminant. And since 56 is positive, that means that we have two real solutions.